Okay, here we go. Section 2 on rational expressions. This is the first one, 2.1, and we're going to deal with a bunch of terminology and just looking at simplifying and what that actually means. Okay, so first of all, what is a rational expression? A rational expression, some of you might think of them as fractions, and I guess what we need to remember is how we deal with fractions, but that we'll do that next section. Right now we're just going to talk about what a rational expression is. And it's basically defined as this, as the quotient of two polynomials, okay? Two polynomials. Now maybe you don't remember what a polynomial is, so quickly run over that too, okay? A polynomial is simply a string of terms, okay? So if we had something like 2x, that is a term, that is a polynomial, it is a monomial. If I add a number in there or anything else, it could be a y or a t or then that is two terms, so we call that a binomial. If I now add a third term in front, we have a trinomial. They are all polynomials, but what you'll notice that they all have is a variable, okay? They all have a variable in them. So what this basically means is an expression on the top and then an expression on the bottom, they will have the same variable, an x, and we need to find out what that x is, okay? So essentially what we're looking at is variables in the denominator. So that is what we are calling a rational expression. Hopefully you understand what polynomials are, if you remember. And then we'll look at a couple other things here. Now, if I have a variable in the denominator, okay, if we have variables in the denominator, it means that we're going to have some restrictions, something that x cannot be or something that your variable cannot be. So think about what domain and range are. Again, if you can remember, your domain is all your x's, right? It's all your x's, and your range is all your y's. Now, I'm just bringing that to your attention. We're not necessarily going to dig into that too much right now. I just wanted to remind you of domain and range, okay? So restrictions is what we're going to have to look at, because what we cannot do is we cannot, ladies and gentlemen, you cannot divide by 0, okay? You cannot divide by 0, so we know that the denominator cannot ever equal 0. So what we need to do is we need to identify what we call these non-permissible values. Okay, so we need to look at what can exist in the bottom that could potentially make it 0. So if I just said 1 over x, right? Well, many of you are going to be able to tell me right away that x can't be 0. That's it. Done. Now, even if I have a 2x down here, it still can't be 0. If I have an x squared, it still can't be 0 because 2 times 0 is 0. 0 squared 0 is 0. So if you just have an x alone, well, not alone, but with a number in front of it or an exponent, it doesn't matter. It's just 0. Now, it's not always 0. What happens, for example, if I said x minus 2 is on the bottom? Well, you know that that x minus 2 can't equal 0. Okay? So we look at it like this. We say, okay, x minus 2 can't be 0. And this is exactly the same as solving an equation. If you want to find what x can't be, well, you just move it over. Minus 2 becomes plus 2, so x can't be 2, and that is essentially my restriction. This is going to happen over and over and over and over and over, right? If I told you, how about 1 over 2x minus 3? Or let's go 2x plus 3. Well, let me slide this up here for you. What about 1 over 2x plus 3? Well, we look at the bottom, we say, okay, 2x plus 3 can't be 0. Well, let's see what 2x, well, it can't be negative 3. Then we divide both sides by 2. And you get x can't be negative 3/2. This is a very simplistic way of finding the restrictions, okay? And these restrictions are actually going to be part of our answers as well, okay? So we have to do both. Now, we're going to look at simplifying, rational expressions. And a big part of that is that we need to now look at what simplifying means. We've done this with fractions before. I have told you already in class that I don't ever want to see an answer like 4/6 again, because you guys, you know that you can reduce that or simplify it to 2 over 3. And this is part of simplifying, okay? Understand that these are what we call equivalent expressions, okay? They equal exactly the same thing, and we can do this all the time, right? We multiply the top and the bottom by something to make it the same thing, just easier to deal with. We multiply the left and the right side by the same thing to make it easier to deal with, you know? So you've done this before. You've dealt with equivalency, right? When they're equal things, just different values, but you end up with the same answer. And we also have reducing or simplifying as part of this, okay? So one thing that I really want to bring across here is I've seen this happen a lot. If you have something like this, okay, what a lot of people have a tendency to do is they tend to cancel this out like that. Now, unfortunately, I'm going to tell you that you're not allowed to do that, okay? You cannot cancel or simply like cancel individual terms. They actually have to be factors. So if I gave you something like this, right? Notice at the top here, you can actually factor out a 2, then you're left with x plus 2. This is basic factoring that we're dealing called GCF factoring. You definitely need to get that sorted out all over 2. Now that these are both factors, right, the 2's in front, we can cancel that out, boom, and x plus 2 is my answer, okay? So one of the first statements I want you to grasp is this, that you can only cancel common factors and not common terms, okay? That's exactly what I'm trying to show you with this right here. Okay, just give me a sec here. I'm going to move that. There we go. Okay, simplifying now. The next thing, what we're going to do is we're going to factor the top. Let's just write all this down, and then I'll give you a bunch of examples, okay? We are going to factor the top, and you're going to factor the bottom. And then we just do some slashes. But before we do that, ladies and gentlemen, we actually have to deal with the restrictions. So let us go through a few of these questions. Let's have a look at 4x minus 8 here, okay? I can take out a 4. What's common? The GCF, right? The greatest common factor is a 4. And you're left with x minus 2. On the bottom, same thing, 5x minus 2. Now, these are the same factors. Cancel it out. So you actually have 4/5. One of the points that I made here was that you have to, so factor top and bottom, that's what we did. Reduce the common factors or cancel them, done. And then state the restrictions. Well, you notice that in your answer here, you don't have any restrictions because there's no variable in the bottom. But what we can do, or what we have to do actually, is look at the original expression in factored form. You can see that x can't be 2 because if x minus 2 is equal to 0, that means x can't be 2, and that's the restriction for this expression. So the answer has to include the simplified expression along with the restriction, okay? Now, what we are going to have to remember is how to factor certain expressions. The GCF factoring, one of the first things you want to do, find a common factor and take it out. If you have no idea what I'm talking about, there are Math 10 videos that I've made that deal with factoring. You need to go look at those, okay? I'm not going to spend a lot of time here going over it. I'm just going to remind you. Now, this is what they call a difference of squares. If you can't remember how to factor this, I highly suggest again that you go look at those grade 10 videos. You'll see once you break this down, right? Why don't we identify our restrictions right away? This one tells me since x minus 3 can't be 0, right? Can't be 0, so x can't be positive 3. And if you do the same thing here, you'll see x can't be negative 3. There's your restrictions. Did before we slashed. Slash. Now understand that if you get rid of something entirely on the top, it doesn't mean there's nothing there, a 0. It means there's a 1, because anything over itself is always equal to 1. So you have 1 on the top, an x plus 3 on the bottom, and this whole thing in its entirety is your solution, okay? The third one over here, give it a shot, pause the video, but I'm going to do it right now, okay? Let's have a look. So notice what's the same, the x squared, x, so there's absolutely an x in the GCF. Y and a y squared, I have a y in both. What I have left is an x plus a y. On the bottom, I can take out a y. What I'm left with is x plus y. Well, right now we need to state the restrictions, and these are pretty weird. Look, y, again, it's alone, so y can't be 0. Here we have x plus y. That can't be 0. Well, this is kind of weird in the sense that I get something that you might not have seen before. X can't be negative y. But that covers pretty much all the stuff, so we don't have to really worry about it. You know, those are the restrictions. They make sense. So we'll just accept that for now. Notice that, boom, that cancels. Notice those go. So your solution is simply just x. And those are your restrictions, so you have to include the whole thing. All right? sure about these examples, you're more than welcome to talk about them with me during class. Maybe bring them up. So now we're looking at these trinomials. These are a little bit trickier to factor. Again, we'll go over them in class. You can look at the videos sorted out. We know that x and x has to go in the front. Then we look at numbers that can multiply to give me 6, which is 6 times 1 and 3 times 2. I'm looking for a negative 1x. That's going to be minus 3 and a plus 2. This is what we call a difference of squares, x minus 2, x plus 2. What we can do now, we state our restrictions. X can't be positive 2 or negative 2. Gone. Here is your entire solution. Okay? And those, so we need to figure out the factoring, ladies and gentlemen. This is the easiest factoring we're going to get. Again, if you're having issues, look at the Pre-Calc 10 videos for factoring. Okay? If you can't find them, I'll show you, but if you're on the playlist, if you're watching this, it shouldn't be hard to find. It's in Pre-Calc 10, all right? One more trick before I sign off here, ladies and gentlemen. I want to bring up a point here. These look very similar. Now, let's just draw an analogy here. Addition doesn't matter. If I have x plus 2 and 2 plus x, these are exactly the same. Think of if x was 3. 3 plus 2 is 5, 2 plus 3 is 5. It doesn't matter. The problem lies when we have a negative. Okay, now you can't, the order matters. If I put if x was 5, 5 minus 2 is 3, 2 minus 5 is negative 3. It doesn't work, they're not the same. Okay, but it does look like we might be able to make them the same. Well, let's take the bottom one, 2 minus x. Understand that if you have just a number at the front, there's no sign written, but it's implied that it's a plus. Let's rearrange it so it's the same order as the one up top. Notice that the x has a minus in front, so it's minus x plus 2. All right, so this now becomes x over 2, or x minus 2 over minus x plus 2. Now they're in the same order, but the signs are all mixed up. This is a trick that's going to happen over and over and over. If you want to change the signs, you factor out a negative 1. So if, negative 2. So if I factor out a negative 1 of the bottom here, if I factor out a negative 1, that means that this changes to a positive x, this changes to negative 2. What you've now done is you've made the same binomial. Let's state our restriction. X can't be 2 from here, right? X can't be 2. And then cancel that out. You've got 1 over negative 1. The answer is just negative 1 with the restriction of x can't be 2. If that's too fast, folks, give me some feedback. I believe that all the information you need for this first section is there. We're looking at page 52 to 55 in your book. Page 52 to 55 in your book should be the questions that you try. Okay, get ready for installment 2.